Hello, my name is Rachel. Today you are about to witness some science electronics. This is the electronics of robotics. The grade I am aiming for in this assessment is an A. What you'll see in this presentation? Footage of a circuit in the making, how circuits work, parallel and series circuits, the definition of what these technical words mean, plus a whole lot more. Let's explore. The first thing we're going to look at is the design and application of breadboards. So, what is a breadboard? A breadboard is a board that's used for making an experimental model of an electric circuit. Let's look at its design. These are the binding posts, the dip support or middle divider, the terminal strips, and the power rails. These will function to create electricity. Now, in order to make the electricity, you'll obviously need some components. There are hundreds of pieces to make electricity, but let's look at how to make a simple LED light glow. We're going to need the breadboard, a battery, a button, an LED, a resistor, and some wires. We'll first place the button across the dip support or middle divider on the breadboard. Next, we'll bring in our LED light and place it here. We need to make sure though to remember which side of the LED is placed. Anode is the longer side and cathode the shorter, so we should put the longer side facing the right as it is closest to the positive rail here. Then we'll put in our resistor here. Now for the wires. We need to connect all these components together for electron flow. We'll place it so that it's in line with the resistor and across to the power rails. Then we'll put another here, so the LED is connected to the button. Finally, we'll put two more wires on the power rail, one on the positive and one on the negative side. All we have to do is bring in our battery, hook the wires to it, making sure we place them to its correct side and press the button. Voila! The LED glows. Let's build another circuit. This time it's going to be a temperature sensor circuit. This means we'll be able to tell what the current temperature is. We'll need a breadboard, an Arduino, and an LM35 temperature sensor. A temperature sensor is used to measure the temperature of the engine coolant of an internal combustion engine. The data from this sensor is then sent to the engine control unit, which is also known as ECU, but in some engines the sensor is used to control an engine cooling fan on and off. As the sensor's temperature changes, its resistance changes accordingly, so the resistor will either increase or decrease, depending on the type of sensor being used. The LM35 is a precision integrated circuit temperature sensor. Its output voltage is linearly proportional to the Celsius or centigrade temperature. This sensor has 3 LEDs, which all have a different job to do. So it's important when connecting the sensor to the Arduino to make sure the LEDs are linked to the right pins. The first pin, VS, will be joined to 5V. The second will be ground to ground. And the third pin will be the analog IN A0 to VOUT, or voltage output. Now for the code. Let's take a look to see what it means. The intersensor pin indicates the analog pin. The setup tells the Arduino how the circuit will run. Then the void setup. This is the serial begin, which, as it states, is connected to the computer, which is how we get the temperature data. Finally, we have the void loop. As stated before, this loop continues over and over again, and it explains to the serial monitor and temperature sensor exactly what to do. So all we have to do now is click Start Simulation, enter the serial monitor, and it will tell us the degrees Celsius or Fahrenheit what the current temperature is. And this 0.25 volts data is the thermostat, which is the resistor. This is telling us how much electricity is required to give us the temperature readings. How to construct series and parallel circuits. A series circuit is when the current through each of the components is the same, as is the voltage across each component. So in the diagram here, we can see that lamps A and B are along the same wires. In a parallel circuit, the voltage across each of the components is the same, and the total current is the sum of the currents through each component. When you put light bulbs in parallel, you get a small resistance, but they draw a current, so they will glow a lot more. However, you use up your battery faster. So we can see here the lamps are in parallel to each other instead of being in one line or a series. An advantage of the parallel circuit is that if one of the bulbs blows, the other will still shine. Voltage in an electric circuit. Voltage is an electrical force or potential difference expressed in volts, the difference in charge between 2 points. The symbol for voltage is V. Then what does the connection of voltage to energy in an electric circuit mean? Well, in a circuit, we have the battery or energy source. This source of energy has positive and negative electrons. These electrons pass through conducting pathways to a point which requires the circuit to be completed or close to work. When the circuit is closed, electricity is produced because the circuit is complete and electricity is flowing. When the circuit is open, there is no flow of electrons. An example is a simple light circuit, such as the one we did with the breadboard. When we close the circuit, the voltage will flow, creating electricity, and the bulb will glow. Measuring voltage. Measuring voltage in parallel and series electric circuits. To measure voltage in a parallel circuit, we must note that voltage is the same across each component of the parallel circuit, so the sum of the current through each path is equal to the total current that flows from the source, using the formula. To measure voltage in a series circuit, we calculate the total resistance of the circuit in order to figure out the amperage. To do this, we add all the individual values of each component in the series. The formula for this is RT equals R1 plus R2 plus R3. An example is R1 equals 2, R2 equals 2, and R3 equals 3. Therefore, R1 plus R2 plus R3 is 7 ohms. To measure voltage, Ohm's law says 1 equals V divided by R. So where RT equals 7 ohms, therefore, we assume a battery or power source of 9 volts is 1 equals 9 divided by 7, which is 1.29 amps, where total resistance equals 1 times RT. So what's an electric circuit? An electric circuit is a path in which components from a voltage or current source flow. Let's look at this example. Here is our battery, lamp, and the resistor. So how does the lamp glow? Well, you have to have a current and electron flow which comes from the battery. The current is a flow of electric charge, which is going to move in this direction around the circuit to help the light bulb glow. And here's the electron flow, which is what we think of as the electric current. There are 2 types of electron flow: direct current, DC, and alternating current, AC. This is a direct current, as we get this electrical flow, batteries and solar cells, when electrons travel in one direction only. And we can see here that the electron flow is only moving in this direction. Therefore, this makes the light bulb glow. How to construct series and parallel circuits. A series circuit is the current through each of the components that is the same as is the voltage across each component. In a parallel circuit, the voltage across each of the components is the same, and the total current is the sum of the currents through each component. When you put light bulbs in parallel, you get a small resistance, but they draw more current, so they glow a lot more, but you use up your battery faster. Resistors, resistance, and measurements. A resistor is an electrical component that has a specific, never-changing electrical resistance. These help to reduce and limit the current flow in a circuit, and at the same time act to lower voltage levels. These are passive components, which mean they only consume power and can't generate it. Resistance is measured in Ohm's law. The symbol for this is here, and this is the formula we use to calculate it. Ohm's law combines the elements of voltage, current, and resistance. It states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points. The microprocessor. A microprocessor is a component in many devices such as computers, calculators, and cars to control specific functions. It is a circuit chip containing millions of very small components such as transistors, resistors, and diodes that work together. It is an integrated circuit that contains all the functions of a central processing unit of a computer. It specifically processes binary numbers, zeros and ones. Finally, what's an LED and how does it work? LED stands for light emitting diode. It's a small device that emits visible light when an electric current passes through it, which is used in a breadboard. The LED has different lengths than the LEDs. One side is longer, which is the positive side, anode. The other is negative and shorter, called cathode. When an LED is placed on a breadboard, it's very important to place the correct side of the LED to match the power source.